record, I think, just in case, for those who can't make it, we might actually cover something interesting today. And I'll share my screen as well. Okay, so you should be able to see my screen, right?
Yep.
I'm trying a double screen thing here so I can see the book and my screen at the same time. Is the dark mode awful for you guys?
Nope.
Okay. Okay, so what I was talking about with loading the data is you need this package, DMWR2, and you have to load the library as well, and then you can run the code just like it says in the book. So yeah, and then from there I was just playing with some of the visuals because they look cool in the book, but I'm curious to see if anyone has gotten tripped up on anything so far. No, it should be pretty straightforward now that we know how the book works, and not to include the carrots and the plus. Are those carrots? What are those called? The little, they're not carrots. These things. And the pluses.
Yeah, they're sideways carrots.
Are they still carrots? Yeah, I don't know if they have a name or not. Funny enough, I called something a pound sign and I got like blank stares from like a teenager, and I was like, the pound sign, and then I had to show them and they're like, that's a hashtag. So here we are. In my day, it was pound sign. Okay, well, I'm really excited to hear. I don't know if anyone's gotten very far. I'm really curious about two things. I'd like to know if you're able to work through it pretty fast. I've been breezing through the visuals in the data discovery section without too much trouble. And then whether or not there was any issues like with the book or something not working. So, but if nobody's really worked through it, then.
Do you want to go back to where you showed what package we need to load? Because I'm not sure if you were recording then.
Yeah, it's this library, DMWR2. And the tricky part about the book is they tell you, let's see, loading the data.
I think that's on like 192. I think Esther let us know in our teams about that.
Oh, nice.
5. Yeah.
Oh, what a great class. Yeah, so it's buried. It says you simply load the book package with a footnote. And then you're like, well, what is the book package? And then I actually looked for a package called book because I'm special at that. And then I went down here to the footnote and it says follow the instructions in 2.1, and that's how I figured out they're talking about this DMWR2 package.
Yep.
So, and then a lot of this section with the initial data, like visualization and summarization, is nice to work through. One, because you get to practice putting together ggplots, which the syntax is weird, so it's nice to just follow along and create some more ggplots, and also learn how to do some of the more custom features of ggplots, which I think until you start actually doing them, like off the top of your head, it's just hard to know like how to add a nice line or a summary line or whatever. So you get to do some of that. And then let's see, we have this fancy box plot. And then I like how they tell you how to like identify outliers, inspect variables a little bit further. Just kind of the things that you would do as a data analyst or a data scientist if you were exploring a brand new data set. So I definitely encourage you, if there's any section that you are going to spend a little more time on, the front sections to me are more important than the back sections. I think the modeling is interesting. Some of it is a little mathy. So I don't want you to stress about like understanding. If you get to the regression trees section and you don't really follow, it's fine. it might be worth trying out the code since it's there for you to see the results, but like I don't, I'm not gonna ask you to like do any mathematical proofs or anything crazy in the class. It's just a different way of building a regression model in R. And so sometimes like with this data set, we just don't have any really good solid candidates for traditional linear regression. The correlations are just kind of weak. So that's why they tried two methods. But if all you did was read the regression tree section, I would not be devastated. So, and hopefully everyone saw my announcement about the homework, since this is like the first time trying out this book and these case studies and people are in different places. It's more important to me that you like read through it and kind of understand the basics than spend, like hours and hours trying to get the code right. So, don't, if you get through a few plots and it's taking you a while and you just want to like read through the rest and look at the book and then move on to the next section, it's totally fine. Just turn in whatever you do get through. I do also really like this section 452 because it goes back to what we've already touched on before with omitting missing values, but it gets a little bit more scientific. So that's definitely another section worth looking at. So how did everyone do with the content in the module and Kurt's explanation of linear regression? Was that suitable enough? Okay. Alrighty, well, yeah, I'm here for you guys, so.
Well, I had a question, and it's not about this week's because I'm still catching up. My question was, I was working through our other textbook, not the one with R, but the other one.
The data mining with our.
It wasn't that one. It was the other
business. Yeah, I know what you mean.
Yeah, and I was working through, I found some really interesting stuff, and it had where you could do a heat map, and so I did that. And then it was having me do another heat map, I believe. And I can't get the code to work. It's the ggplot with melted.
Oh, okay.
And I could not get that to work at all. It said it doesn't recognize melted.core.mat. And I tried looking it up and I couldn't figure it out.
Which section was it in? Let's see.
It was in our other book.
I have it up. Oh, here.
I think section 5, I think, is where I was.
Were you in the chapter 6, the multiple linear regression chapter? Oh, you were.
I think
you're not in regression yet.
I think I was in chapter 5.
Okay, so that had like oversampling.
And we were looking at, let's see. Let me see. I'm sorry, I didn't even think to have where I was looking.
That's fine.
Let me see if I can find it.
I find this book very verbose.
Yeah.
And it's supposed to be like for people who've never used R, but I would not buy that a day in my life. I did not think you could just pick this book up and.
I think it was.
Was it in the data viz chapter by any chance?
I think it might have. Is that chapter 5?
It's chapter 3, but it's got the. Let's see. There's the heat. Well, no, that's the correlation.
Yeah, it might have been right through there. Yeah, it was right through there.
Okay, I'm looking for the heat map.
So I think it's after that.
There's so many things in here. That's actually pretty cool. The network.
Very cool. Very cool.
Tree maps. A map from 1994, apparently.
So maybe it was 3. Let me look at 3.
Oh, no, that was the end. Did I
Huh.
miss- Was it the correlation one? This one?
Yes, it was right after that. It had, oh, it's right in here. It's the bottom one, the melted. So library reshape. So if you go back up,
Oh,
right
okay.
here at the bottom.
Oh, right there.
Yeah. So it was the alternative plot with ggplot. And when I got down to the core.map, I think it stopped working.
Okay. What did it tell you that you don't have that function? by
It
any chance?
said that it didn't recognize the core dot melted dot core.
Yeah, there's a library that you're gonna need. Let's see, what would it be though?
Matt. Well, it told me to load the shape or reshape library.
Okay,
So wait a minute, let
so you
me
would need to install the reshape
forget
package.
it. It works now.
Oh. And then call the
It
reshape.
now works. Because I
Oh, yeah,
called
yeah.
the library and I must
Yeah.
have been just really tired.
No, that happens. Yeah, see, they snuck it in right here.
Yeah, I did do that. I think I spelled something wrong and I kept checking my spelling. But it makes a really cool heat map. And I know that.
Yes, it
Yeah.
does.
Yeah.
And it's in a friendly color scheme, so.
Yeah, so it makes that one and then it just made another one and it's all blue and black. Different colors of blue. Really,
Oh,
really
cool.
dark. So I think it's this one, but it's in color. It's really cool.
Oh, this thing right here, this is
That's a black and white one, yeah.
missing values. Is that what that says? Oh my God, what did I do to my screen? Okay.
now
I need to stop moving stuff back and forth. Oh my God, what did I do? Okay, I figured it out.
I don't know if maybe I could show you guys this. It's really
Yeah, here, let's do that instead. Let me stop.
I'm not on the same computer. I have to just show you in my camera.
Okay. Well, there, now we should, let me spotlight you.
I don't know if you guys are going to be able to see this.
Oh, that is pretty.
Wait, let me get out of this, cancel. So that's what it looks like.
Oh, that's really nice. I like that.
I like the numbers. They're big enough to see and they're not all squished in there.
Yeah, I like sometimes I get that image and it's like 8 decimal points and I'm like, please round. I only need 2. Yeah, that looks really good.
Okay, I'm still spotlighted.
Oh yeah. There you go.
Thank you. But that was fun. I really enjoyed that. I hadn't done much in that one book. And when I came across that, I was really interested. And so I did some and it was really cool.
Yeah, that's actually a good chapter. I think that's one of my favorite chapters just because it covers so many different things. More than I think we get to cover in the data mining with our book. So
I did the one where you do it and then it spits out all these different little plots and all these different lines in the plots. It was really cool. I rarely get things to work that are in the book and I'm like, it worked perfectly.
See, so yes. So like this one in the chapter that we covered for the algae, they do this correlation matrix and it's like the worst thing I've ever seen. Like, I don't know how I'm supposed to read this. Can I even zoom? I can't even zoom. I hate these e-readers.
It is so faint in spots.
Yeah, so then you also have the numbers running over. Like, I don't know if you can tell, but like they didn't resize the font, so they run over. And then at this heat scale, to me, it just doesn't like so the negatives are already marked negative. So for me, I'd rather have a heat scale that just goes from light to dark with absolute magnitude so that I can just quickly find the correlations that are strong, regardless of whether they're positive or negative. And then I know if it's positive or negative because it has the negative sign in front of it, rather than having to look on the top and bottom of 2 different color scales to find the strong correlations. And then they also made the text stronger and weaker. It's just like too many things to try and make an interesting graph. And then on the diagonal, they could have just done a diagonal and cut off all of these values here, but they decided to fill them in instead with like a visual. And I'm kind of more like, just pick one. It's like redundant information in the same graph, just choose one thing. But that's just me. It's really easy if you make a core plot to disregard the top or bottom half of the matrix. And I don't know, I don't have it on this computer, but for my doctorate class, I had to build some functions for visualizing data sets and inspecting data sets. And so I can go look on that one after class, and I can post it in the recap. If you ever want to just like only show the lower, I don't know why you would only show the upper half, that would be weird, but the lower half of the lower triangle, I think it looks a lot nicer. So, but anyway, you can see on here, like there's not really, so like one of the best correlations isn't really useful. I can just tell by looking at it. It's like phosphate and orophosphate. So like obviously if one of those is high, the other is going to be high, because I'm pretty sure they're basically like measuring almost the same thing. And then nitrous oxide, what is that? I don't remember my chemistry class. NO3, anyone? NO3 and NH4 are like the only other really interesting things on here, which is why the regression modeling section kind of comes up a little bit short, which is fine. That's part of being a data scientist. So anyone else? Anything you guys want to cover or go over? Or
I honestly haven't even started. This week has been pretty tough at work, and I just joined the meeting to see where we all going.
Okay, that's fair. I really think I just go slow, make sure you're spelling things right. I don't think it will be too bad, because it's just verbatim what the book is doing. And if you do get stuck or something's just not working, just comment it out and move on. Unless you really need that code to do something else later. But by the time you get to like 4.8, if you get to 4.8 and you just read through it, that's totally fine. There's some stuff in here that's really useful. I don't know if the book really covers it super well, but one of the things is like, so they had some test data frames that they ended up with, the test algae, and the algae, I think it's like SOLS, it's supposed to stand for solutions or something. So they want to combine the all of that information. So they use cbind, which is column bind, and it's one way to merge data sets. So that's a useful function to practice. You get to practice writing a little loop, a for loop. So, if you still have energy by the time you get to here, that's great. It's not like a ton of code or anything to write in. It's just the syntax is a little unfamiliar, because I don't think we've done a lot of loops, but that's about as hard as it gets. So we did do that one like kind of practice loop when we were working with the missing values. And I kind of went through how to read that, for I in 1 through 7. So this is going to run across all 7 columns. And then it goes through, it looks like it, honestly, I don't really fully know unless I read through this, but it looks like it's just doing some more work on combining the data frame, and then it's true, and then it spits out the actuals and the predictions. So yeah, so they talk about it here. So, and put it in a single data frame, create an array with 3 dimension that stores all the information to make the predictions for the 7 algae. And then I think they have 7 predictions. And then the first contains the true values, the second contains the predictions. And then I think they're going to use that to compare and see how close the actual was to the predicted value. So like I said, by the time you get to 4.8, if all you do is read it, it's fine. Most of the really good stuff is going to be in 4.3, 4.4, and 4.5, 4.6. And you get to do multiple linear, and then, which is pretty traditional, that would be similar to what you practiced with Kurt. I think the language in here is a little bit cleaner. So it'll probably be look a little bit different. There's your ANOVA. And then the second model is this regression trees. And I think you need R part. So you'll have to make sure you install RPart before you call the library. And then RPart has a function called RPart, which will run like a model for you. So it's really not so much the code, it's like, what does the output mean? And the book will tell you how to interpret the code itself, but that's going to be the case for like a lot of these packages in R. This is really what R was kind of built for, this statistical analysis and modeling. So there's a lot of packages out there that can do different types of regression and different types of modeling. And so a lot of it is doing some research, like when you're doing this on your own, doing some research to find the best package, learning how to use the package, like how to call the functions in it, and then just finding literature to interpret the output. And most packages have their own document in R that explains what each argument in the functions does. And then it should also explain how to interpret it. And a lot of the packages, the authors have like their own website, and they have plenty of resources on how to use these. So so this RPart creates a regression tree, which is actually pretty cool. In 686, she's got headphones. I don't think she realizes I can hear her. In 686, we actually create a regression decision tree by hand with like mushroom poison data. So it's like how to most efficiently tell whether or not a mushroom is poisonous. And you look for the features that define the most variability, and then you split the group off, and then you do the same thing, like what's the second most useful variable for like splitting off my tree. So in this case, it ends up being PO4. And then from there, it branches out. And so basically, if the PO4 level is not greater than 44, then it goes and looks at the maximum pH. And if the maximum pH is less than 7.9, if it looks like if it's in between 7 and 7.9, it spits out this this estimate. And then if it's less than 7, it spits out 26. And then if it's higher than 7.9, it goes back to the PO4 level and looks to see if it's really low or if it's higher than 15. So, and then the tree breaks out the other way. So the package itself does all the math for you, but this is just a really nice visual that accompanies it that tells you how that algorithm is assigning your predictions basically. So it's pretty cool. Definitely worth playing with a little bit. And then I think from there, they play with they just play with the tree a little bit. They do some what they call pruning, which is like really cute. But basically they're just trying to refine some of these nodes that maybe aren't that useful, or are causing like overfitting in the models. So that's it for the algae, just those two models. And the biggest part of this case study is more, in my opinion, the work process for exploring a data set more than anything. Like there, you've got your hands on some cool data. What does it look like? Running some plots, looking for outliers, things like that, dealing with the missing values. So, okay, well,
I did have one question. When we were doing our housing data, you said that we could save the file so that we could go back and compare. And I kept trying to do that and I could not get a second file. It just kept doing nothing.
From the actual, oh no, it dropped my Canvas tab.
Oh, you're under textbooks. Maybe it's there.
Oh, you're right. I was. That's okay. I'm here now. So you weren't able to save one of the files in the resources?
Yeah, I wanted to rename the file so I could keep the original file and then work with it and then change it and then compare it. And I couldn't get that done. I couldn't, every time I tried to do that,
You save as?
it would tell me I wasn't doing something right. And I'm sorry, I don't remember what that error was. So I wondered if you could just walk us through how to take an original file and save it so that we can then use the file that we're working on, and to call, so we just call that file back up by whatever name we renamed it, correct?
Yeah, was it the multi-reg file?
It was when we were, you just walked us through when we were working on the Boston housing. You'd mentioned.
Oh, okay, that would be better.
And I tried to do that then.
Okay, I'll try it. Well, it was an R file though, right?
No, it was the data file.
Oh.
So you had it in R and then you called it up and then
Oh, I remember. Okay, I got you.
I just couldn't get that to work.
Okay. So let's see. So because when we did the replacement for the missing values, it overrode the original.
Right.
So all you have to do is, I don't know why I opened that. Don't need it. So like, let's say I have my algae data here. Before I like do anything to the algae data set, I'm just gonna store it. Maybe I'll pick something clever in a variable. See, I can't spell algae. So now I have I stored it in this variable. So now if I were to run like the NA omit function or something on the algae data frame and it modified back, I'd be able to pull back up the original data frame to do the comparison. I might have done, depending on what that, oh, I might, oh yeah, I might have done this in that last example, because I think that data was coming from like a CSV file or something.
Yes.
And this is already a tibble, so it's already like really nice. So I didn't need to do it, but yeah, so you could do it either way.
Okay, great. Thank you so much.
Yeah.
Just looking at the codes, just curious, why would we say like those, I don't know how that sign is called, but dot 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 and then R, and we say load, or
Oh,
R then data discovery?
yeah, that's a great question. I named my chunks so that I would know what my chunk was doing. So if you put a word right after a chunk, it names it. And then if your code is really long, which in this case, I actually recommend doing that. I would break our sections into like R and then name it like section 4.1, section 4.2. Just because for me, like I know, just loading data is my first step. So all my code for loading my data, I put in a chunk, and then I can run that chunk and my data is loaded. I know it works, it's good. And then I can move on to the next thing, as opposed to like trying to write all the code or like a ton of code and then run it and then get an error and then have to cycle through. I like to break my code into manageable chunks so that if there is an error, I can check it more easily and more frequently, if that makes sense. So I loaded my data, it's good. And then I called this chunk data discovery because in the chapter, it's the data summary and visualization. That was just a really long name for a chunk. And then there are settings you can put in individual R chunks. We don't mess around with it very much, but like one of them is echo. It's already on, which I want it to be on for all your code, because when you print to HTML, I want to see both your code and your output. But if you were writing a paper and you wanted to embed a plot in your paper, so you're typing, not in an R chunk, and then you say, okay, and now I'm talking about a plot, and then you want to show the plot, and then you put your R chunk in for your plot. I don't want my paper to include the code and the plot. I just want it to include the plot. So I would put echo equals false. And then when I compile, it only shows the graph. It doesn't show any of the code. Warning. So if you run this code, it's going to yell at you. It's going to tell you that it's going to run it. It's not going to be an error, but you're going to get a warning. It's going to say this syntax right here, the ellipses, is what do they call it? Well, here, I'll show you. Okay, so it's thinking, okay, so it's, it's telling me it doesn't like my syntax, it's discouraged. And then I got another warning about non-finite values. But the warning I didn't like was, oh, it went away. That's so weird. When I first ran it, it yelled at me. It didn't like this syntax. It told me like it's not, they've oh my gosh, I'm having a stroke. There's a specific word for when they like retire certain syntax, but anyway, I didn't want to keep looking at that warning every time I ran the code, because it's just a warning. It doesn't affect the compiling of the code. So I put warning equals false so that it would stop popping up.
Is the warning in your console part?
It pops up down here, but also like when I was clicking on those pictures, it was popping up. See, the warnings are gone.
Yeah.
So that's all. I was just telling it to be quiet, basically. There's other things you can do up here that we won't need to do in this class, but just for your information, you can set it for evaluate. I do this a lot in my papers. Yeah, eval. So in my doctorate papers, sometimes I just want to show like a part of code because I'm explaining something to the reader about that, if I'm actually writing about our code. But I don't want the R to actually try to compile it, because it's kind of nonsense, because it's just a snippet of code. So I can put eval equals false, and then it will just show the code without trying to compile it. It'll basically skip over it. So that's another option that's kind of useful. And then I'll just say, like, there's other options in the R chunk. You can, if you are doing like a plot and you're writing a formal paper, you can label your chunk so that you can reference it. And that gets like really complicated. It involves another language called LaTeX, but that way, like, I can reference that plot as figure X basically. And then when it compiles, it goes through and it assigns, when I'm all done with my writing, it assigns a number in order to all my figures. And then it goes through the text, finds all my references that reference that chunk and replaces it with that. So if this was like ended up being the third figure in my paper, it would go in the text, find all the times I called out that chunk and call it figure 3. So that way I don't have to like keep finding and replacing. Like, let's say I end up adding another image and it becomes figure 4. I don't have to go find all the figure 3 references in my text and change them. It automatically ties them together, if that makes sense. So there's a lot of things you can do in the R chunk that are beyond the scope of this class, but that's what one thing that is useful is labeling the chunk itself, because you can go, when you're down at the bottom, look, I can see all my chunks right here. So if you're like, code is really long and you're like, shoot, I want to go back to my data loading chunk and add a library, because you if you're like me, you like to keep all your library calls at the front. You could easily just go jump up to that chunk. Or if I'm at the top, I was, messing with something and now I want to go down and find, back to my data discovery chunk, I can navigate a lot faster. So
Understood.
10 out of 10 recommend naming your chunks.
And just another question, since I have this opportunity to ask right away, since I haven't got to the point where I was reading the chapter, but I see we covered a lot. MXPH, maximum pH, what does it stand for? Is it something from the data set itself?
Yeah.
Okay.
I think when you go through to the book's credit, there's, before you start coding, they will tell you what this data is. So it came from a competition.
Oh, it's from chemistry. Gotcha.
Yeah. So oh, here we go. I can find, nitrates. Okay. So, yeah. So you have oxygen, chloride, nitrates, ammonium, orthophosphate, phosphate, and then the chlorophyll measurements. And then I think there's a second test data set. Yeah. So then when you get to the prediction section, there's another data set that has the same structure, but it doesn't include information about these like 7 harmful algae frequencies. So it's kind of like the test set that gets put into the prediction models that you build in the section in 4.7. So yeah. If you have any other questions, I don't think they go much more into it than that though. So if you end up like finding this really interesting and you want to know more about like the orthophosphate, you would have to look that up on your own, because I have no idea. I don't remember any of my biochemistry from college. So. Okay, well, if you guys don't have any questions, I guess we'll just call it, but it was really nice to see everyone.
I had one more question, of course. The videos that you do for these sessions, is there some place we can compile them all together so we can go back to that one place just to look at the ones we want to look at?
Yeah, I don't think I've recorded. I mean, I have the first session, and then the second one was like kind of nuts because we were just messing with the we were like looking online. So that one's pretty long, but I don't know how useful it is. but I can certainly post it. And then the third one we didn't record because it was really short. And
Yeah.
one of them we skipped. So
Yeah, I think we only have like, including this one, there's like 3, I think.
yeah, because 2 of them were, though, and then like when we met on Sunday, it was pretty relaxed, and I don't think we covered anything crazy. So, but yeah, I'll put them on. I have to upload them to YouTube anyway, so maybe I could just create like a content in the overview or something that says like, you know, links to videos. Would
Yeah,
that be okay?
that'd be fabulous. Thank you.
Well, I'm gonna stop recording if we're good. Are you guys good? Rocky, Abu, Rob.
Yes, thank you.
Yes, thank you.
Okay. Well, thanks for joining. If you get stuck on anything, send me a message as you're working through it. Yeah, and then yeah, I look forward to seeing you guys next week. The stock market one should be interesting.
All right. Thank you.